Hello everyone, a very warm welcome to you. My name is D. Hussain. I am currently pursuing MSc Chemistry in Sri Venkateswara University, Tirupati. I am very enthusiastic chemistry graduate and I am here for seeking a position as a chemistry tutor to teach chemistry subject for class 11 and 12 students. And and I can teach chemistry for class 11 and 12 students who are preparing for IIT JEE mains and NEET and state board exams also. And as I am a chemistry graduate and a chemistry learner, and I can teach the topic in a understandable way and easy way. And I can teach the student how to approach the topic to understand in easy way and learn the topic in no time. And coming to the content that I can teach, coming to the content that I can teach for class 11 and 12 students as basic concepts of chemistry as electrons, neutrons, how they function, as all this, and then going to structure of atom, it takes 3 hours, and then classification of elements and periodicity and properties as it, it will be all the information about periodic table. And then chemical bonding and molecular structure is a high scoring subject and it takes topic and it takes more time and it will be more useful in chemistry and it takes 8 hours of time. And then going to states of matter, solid state, liquid state, gaseous state, and it takes 6 hours of time. And then thermodynamics 5 hours, equilibrium, chemical equilibrium, physical equilibrium 5 hours, redox reactions 2 hours. And then hydrogen, about hydrogen, how the bonding forms in hydrogen, it is a monovalent or what its nature, all this will discuss. S block elements, P block elements takes 3 hours and 7 hours. Organic chemistry, in organic chemistry we'll talk about the nomenclatures, functional groups, and uh, general organic chemistry, inductive effects, resonance, hyperconjugation, all this mesomeric effect, all this will be covered. And in hydrocarbons, alkynes, aromatic hydrocarbons, all these will be covered in hydrocarbons. And then going to environmental chemistry, the general overall, all the about the chemistry in everyday life, like that, it will take 3 hours. And then the electrochemistry 6 hours, chemical kinetics 6 hours, surface chemistry 4 hours, D block and F block elements 4 hours. And then coordination chemistry, it is also a very good chapter for a scoring chapter. It will take, it's a lengthy chapter, so it will take 8 hours. And then haloalkyls and haloarenes, all the reactions of these haloalkyls and how they forms, everything 6 hours. And then alcohols, phenols and ethers, aldehydes and carboxylic acid, all of it will take 6 hours. And then organic compounds containing nitrogen, it will take 5 hours. And then polymers 2 hours. Then the concept that I am going to teach each and every in each and every topic, as I can teach from starting basic concept of the topic and then going to the every topic related MCQs, objective type questions, and I'll teach the students how to approach the topic and how to solve the questions. All this will be, I will teach, all this I will teach. And then coming to the demo that I can for now, I will be explain about haloalkyls and haloarenes. In haloalkyls and haloarenes, term halo means halogens, in which means for an carbon chain, mainly for an carbon chain, when an halogen substituent is attached, then it is called as haloalkyls or haloarenes. If it attached to aromatic carbon, then it is haloarenes. If it attached to aliphatic carbon, then it is haloalkynes. And then the definitions of that. Say, the replacement of hydrogen atom in a aliphatic hydrocarbon with halogen atom is called haloalkynes. The replacement of hydrogen atom in aliphatic hydrocarbon with halogen atoms is called haloalkynes. See the example, you can see aliphatic means chain like structure. So C2H5 ethylene, it will ethylene, sorry, ethane, a substituted halogen, so that's why it is haloalkynes. And then go to haloarenes, same, the replacement of hydrogen atom in an aromatic hydrocarbon with halogen atom is called haloarenes. You can see the example, as the benzene ring is the one of the hydrogen is replaced with halogen atom, so this is haloarenes. going to the reactions of haloalkenes, how they react, how they react. All this we can learn in this. The reactions mainly in haloalkenes undergo substitution reaction. Substitution means replacement, just a replacement, not a elimination or an addition, and just replacement. One atom goes, another atom goes outside. One atom comes in, another atom goes outside. That's the substitution. The nucleophilic substitution reactions. What do you mean by nucleophile? Nucleophile is a electron rich species. Electron rich species means it contains of more electrons, like in the form of lone pairs or in the form of negative charge. Those are called nucleophiles. Those are in neutral. You can say H2A is a nucleophile, and the Cl minus is also a nucleophile. You can say H2A, there is no charge, but it is a nucleophile, because neutral atoms are also nucleophiles, and then the charge consisting with negative charge constituted atoms are also nucleophiles. That's why we can say nucleophiles are electron rich species. We can see the definition. The reaction in which a nucleophile replaces already with existing nucleophile is called nucleophilic substitution reaction. So we can see in the equation, Br is a nucleophile, we know, as the Br is replaced with another nucleophile, OH minus. So that's the point here, as Br goes as good leaving group outside and then forms the carbocation intermediate, and then it forms, and then if there is a plus charge, then definitely the negative charge will go and attack on the carbocation. So the another nucleophile OH will attack, and then the product is formed. This is nucleophilic substitution reaction. These reactions follows two mechanisms. So we can see the mechanisms. As you can see, the substitution reactions involved in two mechanisms, SN1 and SN2. Coming to SN2, we can say it is a nucleophilic substitution biomolecular reaction. It is SN2 reaction. In SN2 reaction, you can see in the reaction, it is a single step reaction in which transition state is an intermediate. Transition state will be formed, and then you can see in the reaction, as the another nucleophile OH is attacking from the back side of the carbon, and the another side of the nucleophile Cl minus is going out. By forming a transition state, the product is formed. You can see there here clearly. OH is attacking from the back side, and then the Cl is leaving by forming a transition state, and then the another product is forming, alcohol product is forming by removing of Cl minus. And this is the product. The stereochemistry of this product is Walden inversion. As you can see, the product in the reactant, the nucleophile is on one side, and when you see in the product, the nucleophile is on another side. So it is called Walden inversion. As we can see, it is a one-step reaction. No intermediate is formed. Transition state is formed. No intermediate is formed. Just transition. Transition state is not a intermediate. And then back bonding formation. And rate is depends on how the substrate is and the coming nucleophile. How the substrate and coming nucleophile is, then the rate is dependent on the rate of reaction. As how fast the leaving group goes, then the nucleophile will be attacked. How fast the leaving group, as the leaving nucleophile will goes out, then the another nucleophile will attack. So you can see the rate starting. Iodine is a good leaving group among all the halogens. So iodine starts coming first, and then bromine, chlorine, fluorine. And then the stability of this, as the substrate should be a primary carbocation, primary, and then secondary. See in this you can see in 1 minute. You can see in the reaction here, the substrate is a primary carbanion. You can see And then coming to nucleophile in SN1, what do you mean by SN1? Nucleophilic substitution in unimolecular, then it is known as SN1 reaction. SN1 reaction, as you can see in the reaction, SN1 reaction is a two-step reaction, two steps. It will occur in two steps. As in the first step, as the attached nucleophile, the leaving group will go outside and form a carbocation intermediate. See here, the slow step is, then it is a slow step. It is also called as rate determination step. And if we go to the second step, as then the carbocation is formed, nucleophile, another nucleophile, the outside coming nucleophile will attack on the carbocation and the product is formed. The product that can be formed on both sides, the nucleophile can attack on both sides of the carbon, either the left side or the right side. So it will form enantiomers. So the stereochemistry of SN1 reaction products are enantiomers, forms a racemic mixture, retention and inversion. And we go to see here the two-step reaction, carbocation formation will occur, and the carbocation formation step is a rate determination step. First step, as the rate depends upon the substrate, rate of reaction is directly proportional to stability of carbocation. As the carbocation should be tertiary, then the product is stable. As the product is the carbocation is primary, then it is not stable. Why? You can see why. In SN1 you can see the tertiary is stable, and in SN2 you can see the primary is stable. Why? Because in SN2 the attack of nucleophile will be from the back side. As if there is a tertiary group, then there is a fully bulkiness and steric hindrance. There is no way to come back bonding of backside attack to form back bonding formation. Back bonding. So in SN1 the carbocation should be tertiary, and in SN2 it will be primary. This is the concept of reaction of haloalkenes in substitution reaction by SN1 and SN2. Thank you for giving this opportunity.